complicated rule is the chain rule. The rule of calculating derivatives. Now, this rule applies to very special functions, so-called composite functions. So what are those composite functions? For example, let's say f of x, or call it k of x, equals cosine of 3x squared minus 5x plus 1. So when one function or expression sitting inside another, or you can say one function applies to another function. You may say something is sitting inside something else. So in this example, 3x squared minus 5x plus 1 is sitting inside cosine. Or, let's say, it could be also something like square root of 3x squared minus 5x plus 1, in which case 3x squared minus 5x plus 1 is sitting inside square root. Or it could be, say, k of x equals 3x squared minus 5x plus 1, all of that to the power of 10. So now 3x squared minus 5x plus 1 is sitting inside the 10th power. Anyway, whenever something is sitting inside something else, this kind of function is called a composite function. And there is a special method of calculating derivative. First of all, there is a special notation for functions like this. The notation goes k of x equals f of g of x. So this notation actually represents the function that sits inside is g of x, this is the inside, and f is the one that sits on the outside. Like in the first example, f is cosine, in the second example, f is the square root, and in the third example, f is the 10th degree. And the interior function, the g of x, in all three examples is the same as 3x squared minus 5x plus 1. Now this formula is sometimes written in a shorter way in mathematics, like with a circle in the middle, f circle g of x. This small circle in the middle, we read f composed with g of x. And here is the chain rule. So once again, to calculate derivatives of all of such functions, we need a special formula, which is called chain rule, and here is the formula. So if k of x is a composite function, so it equals f of g of x, or can also be denoted f composed with g of x, then here is the formula for the derivative. K prime of x equals f prime of g of x times g prime of x. So this formula is called the chain rule. And the way it is written, it's quite difficult to memorize. So in order to make it easier to memorize, we can introduce new notation. So we will throw in a new letter u, and this new letter will mean exactly the portion that sits inside g of x, which I want to call interior function. Interior function. And if we use this notation with the interior function, then k prime of x equals, well, if we denote that by u, so we can put u inside here, so it will end up f prime of u times g prime of x. So now it's much easier to memorize. Basically, it says that the derivative of the composite function, derivative of the big function, equals derivative function that sits on the outside, exterior, times the derivative of the interior. So this formula, once again, to memorize it, so derivative of derivative of composite function equals derivative of exterior multiplied times derivative of interior. So that way it's much easier to memorize and actually easier to apply as well. Now, before giving you examples how to apply such a formula, I want to give explanation or proof of this formula. How does it occur that complicated? In fact, the proof is very complicated, and I only want to give you the proof or explanation in one specific case. The other cases are complicated, but just to give you an idea why it appears like this, so I want to give you, if not proof, but just explanation. Again, all those proofs or explanations start with the same. So we start with k prime of x equals, and then put the limit as h approaches 0, k of x plus h minus k of x divided by h. And then we need to expand both k of x plus h and k of x. To the limit, h approaches 0. Well, k of x plus h will be f of g of x plus h, like this. F of g of x plus h minus f of g of x. Like this. Okay. And now, and all that divided by h. And now I want to apply some algebraic manipulations to eventually come up with this formula. So what kind of algebraic manipulations we need here? So here's the following trick. We will multiply and divide the entire formula by the following expression. Limit as h approaches 0, f of g of x plus h minus f of g of x. I want to divide it over g of x plus h minus g of x, assuming that whatever I divide over is not a 0. And then, in order not to change anything, I will multiply times the same, and then it will end up g of x plus h minus g of x divided by h. So we get limit of product of two functions, of two expressions. Now we can split this limit as limit of this first part times limit of the second part. Limit as h approaches 0 of f of g of x plus h minus f of g of x divided g of x plus h minus g of x times, and then the other will be limit as h approaches 0 of the quotient g of x plus h minus g of x divided by h. Now here's what we have. The second limit is actually precisely the definition of the derivative g prime of x. Now the first limit is a little bit more complicated. So in order to calculate this first limit, introduce a new notation. For example, let's call it L. So introduce notation that is L. And L will be g of x plus h minus g of x. Now, since h approaches 0, that means g of x plus h minus g of x approaches g of x minus g of x. So it approaches g of x minus g of x, which is again 0. What it means L, when h approaches 0, so L also approaches 0. So when h approaches 0, which means h becomes small, so L also approaches 0. Besides, we can write, in this expression, we can solve it for g of x plus h. We can isolate g of x plus h, and for that we just add g of x to both sides, so we can write g of x plus h equals g of x plus L. Because we just add g of x on both sides. We do plus g of x, and here we do plus g of x. In this side, g of x and g of x minus g of x cancels, we just get g of x plus h. On this side, we get g of x plus L. So this is what we get. Now I want to expand this second limit. Because g of x plus h is the same as g of x plus L, so this entire thing is g of x plus L. So we get limit as h approaches 0, but I just said when h approaches 0, so L approaches 0, so I will write L approaches 0. And then we have f of g of x plus L minus f of g of x. And the denominator is just L itself, so because f of x plus h, because g of x plus h minus g of x is exactly L. So that's the first limit. And now if you look at it, it's exactly definition of the derivative, f prime, except it is f prime, instead of a we have g of x, so it will be f prime of g of x. So this limit I have just calculated, it equals f prime of g of x. And the second limit equals g prime of x. So altogether it happens to equal f prime of g of x times g prime of x. So this is the explanation. Actually, it's not a complete explanation because I assume that whatever I divide over and multiply times, so this is not 0. If this expression equals 0, then explanation should be more elaborate, and it's very complicated, so I want to leave it alone. But anyway, this explanation explains, or hopefully explains you, like how this complicated formula occurs. It occurs as the result of these calculations.